The authors of today's 3-minute paper created a convolutional neural network for stability prediction and focused specifically on trying to reduce biases in prediction. Their way to do so, with one focus, was to reduce biases in destabilization, including anti-symmetry-based data augmentation to develop reverse and direct mutations that can be implemented in their data sets. They also wanted to look at a unappreciated bias, which was homology between training and test sets in previous machine learning models. By modeling structures in Rosetta and then generating various biophysical property features, they input that information to develop their convolutional neural network and extract the delta G. In their results, when comparing to the other tested models, they found and the benchmark data sets, they found a Pearson correlation coefficient as a difference between direct and reverse mutations being negative 0.96, and a prediction bias being the delta G of reverse plus direct to be negative 0.01. Where perfect Pearson correlation value would be -1 in this case, and a perfect prediction bias, quantifiable prediction bias value would be 0. Although this was just comparable to the best model, it was much better than the vast list of models that they tested, including Rosetta and FoldX. Using a biophysical model of protein evolution that suggested a fitness decrease with increasing deviation from optimal stability within a neutral zone, as shown in the bottom figure, a neutral zone of 1 kilocal per mole, around 0 kilocal per mole. They examined a experimental data set called ClinVar, including benign and pathogenic mutations. In this case, benign mutations should fall within negative 0.5 to 0.5 kilocals per mole, and pathogenic mutations would be equally stabilizing and destabilizing. As a result of their examination between FoldX and ThermoNET, the name of their model, they found that 80.2% of ThermoNET, 80.2% of mutations were within that negative 0.5 to 0.5 region for ThermoNET, and 39.7% were in FoldX were in the neutral zone. For pathogenic variants, they found nearly equally likely stabilizing or destabilizing mutations for ThermoNET, but for FoldX, 83.2% of pathogenic variants were destabilizing. In total, their model was only comparable to the top model, and that was delta G Gun 3D. But when looking at reverse mutations, their model performed much better and reduced the magnitude of prediction bias.